Hello guys, in this video we are going to discuss the solution of the problem sum of nodes on the longest path from root to leaf node. So let us look at the problem statement. The problem statement says that given a binary tree having n nodes, find the sum of all nodes on the longest path from root to any leaf node. If two or more paths compete for the longest path, then the path having maximum sum of nodes will be considered. So for instance, in this example, this is the tree which is given to us, and here the longest path is just 1, which is 4, 2, 1 and 6, and the sum of that longest path is what will be our answer, which is 13. 4 plus 6 plus 2 plus 1, which is equals to 13. Whereas over here in this second example, if you see, there exist 4 longest path: 1, 2, 4, 1, 2, 5, 1, 3, 6 and 1, 3, 7. Of these 4 longest path, 1, 3 and 7 yields us the maximum sum. That is why we are returning 11 in this particular case. So that's about the problem statement, folks. Now let us discuss the solution for this problem. So in order to discuss the solution for this problem, let us take a tree, and let us say the tree is something like this. So let us say this is the tree which is given to us. So the general idea for the optimal solution would be to do the level order traversal. And when we are doing the level order traversal, at each node we are going to compute the sum of nodes so far. So let us do a level order traversal and compute the sum. So over here the sum is 1. When we will come to this node, the sum will be 1 plus 2, which is equals to 3. Here the sum will be 1 plus 3, which is equals to 4. Similarly for the rest of the nodes. So this is the sum at each of the nodes. Now towards the final step, what we are going to do is, if the node is a leaf node, and before we come to this particular case where the node is a leaf node, what we are going to do is we are also going to maintain the level of the tree. So this is at, let us say, level 1, this is at level 2, and these nodes are at level 3. So with this much of information, now let us say we are at some node which is a leaf node. Once we are at a leaf node, what we are going to do is we are just simply going to check two conditions, which is if current level is maximum than the answer level, and let us say the answer level we will set it to some negative value, -1. So if current level is greater than answer level, so we know that now let us update our answer level. So answer level becomes our current level, and the sum which we will see over here, which will be our answer, let us say the answer what we need to return, will update the answer with the current sum which we have. Okay. Now let us say this is not the case. Current level is not greater than answer level. So it might be possible that the current level is equals to the answer level. In which case, as per our question, we need to compare the current sum and answer, right? So the maximum of the sum is what we need to return. So if current sum is greater than answer sum, then our answer will be equals to, oh sorry about this, this is just answer, is equals to current sum. These two conditions is what we are going to check for all the leaf nodes. And towards the end, what we are going to do is we are going to return our answer. Okay. So that's the basic idea, folks. Now let me just do a quick recap of it. So the basic idea revolves around two concepts, which is, first we will do a level order traversal, and while doing the level order traversal, we will also go ahead and compute the sum which we have seen so far. So in this case, 1, 3, 4, 7, 8, 10 and 11. While computing the sum, we will also maintain a variable which will hold me the current level we are at, which is 1, 2, 3 and so on. Once we have these two information with us, we are going to make our comparison, which is, if there exists a level which is greater than my answer level, then the sum obtained at that level will be my answer. Otherwise, if the current level is equals to the answer level, then I need to find the maximum sum, which I'm finding it like this, and towards the end we are returning answer. So that's about the explanation, folks. Now let us go ahead and see how we have coded this. So in order to code this, what we have done is we will go ahead and perform a level order traversal. So for level order traversal, as we know, we need a queue. So this is the queue which we have, and we are storing two information in the queue, which is the node, which is the root node in this case, and the sum we have seen so far. The sum we have seen so far is 0. That is why we have marked it as 0. And then we have something called as current level, which is initially the value I have set it to 1. And then I'm appending none and 0. This is just to indicate that a new level has been encountered, such that I will go ahead and increase my current level. Then I have my answer and answer level. Initially I have set these values to -1. Now let us go ahead and do a level order traversal. So while the queue is not empty, we are performing level order traversal. We are popping the first element of the queue, and we are getting the root from that one and the previous sum which we have seen. Now the current sum let us initialize it with 0. Now if the node exists, then the current sum will be equals to previous sum plus a root of data. Now if this node is a leaf node also, and the leaf node condition is this, then we are going to perform those two checks which we have discussed, which is if this is the maximum level, then let us update our maximum level, which is answer level equals to current level, and also update our sum. So answer equals to current sum. Otherwise it might be possible that the current level equals to answer level, in which case I need to find the maximum sum. So this is how we go ahead and find the maximum sum. If this is a none node, in which case I have encountered the end of the level, so I will go ahead and increase my level by 1. And if queue is not empty, I am pushing none to it. And towards the end, I am just checking whether the root.left and root.right exist. If root.left and right exist, then I'm appending that value in the queue with the current sum. And then towards the end, I'm returning answer. So that's the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.